Hi folks. So I have a coworker that came by my desk one day. I have an old Pioneer integrated amp up there, a set of speakers, and he admired it. He goes, "Oh, this is cool stuff. I wish I could find somebody who knew how to work on this stuff." Well, you know, we had a conversation after that. So this gentleman, whose name is, well, we'll call him Matt because his name is Matt, and he has an older Onkyo surround sound receiver he wanted to have fixed. Now, I didn't realize it was a surround sound at first, and when I saw it this morning when he brought it in, I told him that frankly, in today's market, older units, especially the ones like this without HDMI, are virtually worthless. You could pick them up $50 on Craigslist all day long. Nevertheless, he does want this fixed, and it looks like it has a pretty minor problem. So let me move the camera in and show you what's going on. So apparently when he was moving, the front took a shot and it broke or pushed in the balance knob. So we're gonna have to pull the front panel and see how far we have to disassemble this to get to this, but it probably bounced on the back of a small circuit board, or it may have cracked a larger assembly here. We won't know until we take it apart. The other thing he's complained about is he said some of the buttons on the remote aren't working anymore, and I would guess they're the commonly used ones. I used to have a photo transistor permanently wired with a resistor and soldered to a D battery, and I would use those to check a remote. I would just connect my oscilloscope probe across it, and I'd aim the remote at it, and I could see the pulses on my scope. But these days you don't even have to do that. All you have to do is turn on your smartphone camera and hold the remote like so, and hold the button, and you should be able to see the pulses. See those purple pulses there? That's how you can check them out really easily. And what he's saying is some of the buttons on this don't work. And I'm not seeing anything here, and it feels like it's got batteries in it. Yeah, that one's working, if you can just see that little flashing purple dot there. But some of them aren't. And what we're going to do is we're going to crack that remote open, and we're going to use some conductive paint to recoat the buttons that have poor conductivity. And probably the hardest part of this job usually is just getting the remote open. So we're going to take a look at that. Meantime, I'm going to pop the cover off and see what kind of disassembly we're up against here. Okay, so I've gotten into the unit, and if you look here, here's what the controls should look like. I'm not sure how well you can see this, but this is the balance control, and it has been broken. Here's a piece of it I found inside. So I'm gonna have to see if I can source another one of these. I was hoping it just snapped the board it was mounted to, but the control itself is pretty well destroyed. So we're gonna have to see if I can find one of these somewhere. Shouldn't be too hard. This may at least be something I can find either on eBay or perhaps in the junk unit I have laying around here. We'll have to take a look. Okay, so the knobs just pull off here, and there were nuts like this around each one of these shafts. Actually, this one was missing. I'm kind of unsure what could have happened to it because I don't believe the owner took it apart. But anyway, those come out, and then if we look inside, let me just move the camera a bit. If you look right down here, there's a screw right here that has to come out. And if I take that out, I should be able to get the board out. Okay, like a lot of units I work on, they built everything around the board that I need to gain access to, so I wound up having to pull the front panel. There was not enough room between the motherboard and the back of the tone control board to pull it out, so I had to pull the front off in order to gain access to this. But now that I have another problem, and that is I do not know what the value of this pot is, and I need to find another one. The value is written on the top, and the top is not the piece that I found. I'm going to see if it's fallen in here anywhere, but without that, I'm not really sure of what we need. Oh, you know, I may actually have the top. Yeah, that piece I found did have the top, so at least I have the information. I'm going to see if I can find another one of these. I'm going to measure it, see if I can find a manufacturer, and see if I can replace this thing. It just happens to be these two are the same value, but this one is different. All right, so I was able to find a substitute for that pot, but before I talk about that, I also want to talk about tools. Now, you guys have seen I have a bunch of expensive test equipment. I've had many comments about that, but there are some tools that are just a great bang for the buck, and I have to tell you, this is one of them. This is a digital micrometer I picked up at Harbor Freight. I got this about 10 years ago, maybe a little longer. And as I recall, I paid about 20 bucks for it. And I'm happy to report that even after the bout of inflation we went through in this country, mild by some other countries' standards, that this thing is still 20 bucks. And if you're going to be replacing things like that, it's imperative that you have a good way to measure them. And this is a great tool. If I had to replace it, I'd buy it again. Harbor Freight doesn't have the best quality tools, but this has been fine. And for things you only use once or twice a year, there's no problem with buying stuff there. If it's something you make your living with, something that you use that's very, that has to be very durable, it may not be the best bang for the buck, but for those of us who just use tools occasionally, that's fine. And there are things like this that are just great. There's a site I found called the Garage Journal, I think it was, and they had a Harbor Freight tool pass-fail thread. Great reading. There's some tools that are just a great bang for the buck, and I have to say, this is one of them. Anyway, I was able to get some pots that matched. Because I had accurate measurements, because I knew the value, I was able to go to Mouser, and I got some... I got a really good match. Now, I picked these up. These are Bourne's pots, good quality. They dropped right in. The pin spacing was great. The frame was great. They're a little bit different, and I'll show you a picture. But the biggest problem was that the shaft is too short. The other one stuck out to about here. So what I wound up doing was I bought two of these because they were less than $2 each, and I disassembled one. This is the frame from the original, and this is the post from the original, because what I did was I took this out of here and I put in the one from the other one. The diameter was perfect and it worked fine. And then of course I took it apart again because there's a small ring that mounts inside of here, and it has the detent on there that you have in balance control, so when you're in the center you feel that little click. So I was able to get that in. I thought for sure I destroyed it, which is why I bought two of these, but yeah, that worked out okay, and I was able to get everything just reassembled. The one problem I found was when you buy a potentiometer like this, it's not only the resistance you have to match, but you also need to match whether it's a linear taper or an audio taper. You may see linear or logarithmic, linear log, lin log. You may see things like that. They may say audio, but I didn't get the correct taper. It's a balance control, and I thought about this. Balance controls, in my opinion, are just another point of failure. We rarely use them. They usually stay right in the center. And too often like this, I've found myself having to find a replacement, repair the one that was in there. And some audio equipment even comes without them. So that was the solution to this. I was able to get it back together, test it out, and it works fine. Now the second thing I had to do is work on the remote. So we're going to talk about that. The other thing that the owner said he was having a problem with was the remote. Now, I had to open this up, and these things are usually just made to snap together. So what I found is the best tool for getting stuff like this apart without damaging them is I took a putty knife and I sharpened the edges of this with a file. You could shave with this thing, and you can put it in and basically just kind of pop the case open. This had one screw in the back that went right here. And what happens to these is you have this pad that has conductive carbon on it. and the commonly used controls tend to wear away after time. Now in this case, one of the most commonly used ones was down here at the bottom. It was the volume up, volume down. And I put some coating on one of them. We're going to take a look with the ohm meter, and I'll show you what I found here. See if I can get everything in the frame. But if you measure these pads, this is one I haven't done yet. And it's pretty much, see, it's pretty much done. This is one I put some conductive coating on. You can see that's in the hundreds of ohms. Most of these measure in the thousands. But that should work well. Depending on how often the buttons are used is how quickly they will wear. So what I did is I bought this conductive paint, conductive graphene resistance coating, water-based. And I shook it really well. And I think it could have been mixed a little better, or even had a few drops of anhydrous alcohol put in it. But in any event, I put it on here just a couple hours ago. I'm going to let it dry really well before I actually reassemble it. I'm going to check all the pads. I should have checked everything before I took it apart. But as usual, I didn't really think about it. And I know the ones that have no resistance, like that one, need to be done. So I'm going to go through, I'm going to check them real quick. Any of these that look like they're suspect, you're going to get a fresh coating. And we'll reassemble it. And I believe the owner said there were some problems with some of the surround sound functions. We'll take a quick look at that. But honestly, I don't want to put a lot of money in this, or a lot of time in it, because it's simply not worth it. And these are the major complaints he had. So we'll take a quick look at all the other functions when I'm done. But this is probably the last thing I'll be doing with this. And I want to talk a little bit about finding the right pots, how difficult it can be. But in this case, we got something that fit and works. So I'm happy about that. All right, so I resoldered the 3-terminal regulators. What they got going here is they have a small power supply, puts out positive and negative 21 volts, 21.6 and 23, whatever. And it feeds 2 sets of 3-terminal regulators. I initially thought they were transistors because of the printing silk screening on the board, but I just couldn't see it well enough. They are indeed 3-terminal regulators. These put out plus and minus 12 volts. These put out plus and minus 6 volts. And these had essentially unsoldered themselves. If they get hot enough, components can do that. And these apparently got really hot. So I resoldered those, and I really thought it was going to clear up the problem, but it didn't. So now what I've done is I've got the front panel taken apart. This is more or less an audio block diagram of this unit. Now, bear in mind, this is at best a $50 surround sound receiver. I made it clear to the owner this has virtually no value, but he bought it a long time ago. He's the original owner, and he wanted to have it fixed. So I'm willing to go through it. I'm not going to charge him much because he is a friend. But anyhow, they can be a real bear to work on, and they're very complicated. And if this doesn't fix it, I'm not sure if I'm going to go on. But anyway, let's go through what happens here. So I know I'm good through 2-channel. So I know I'm good through this. This is a analog switch IC. I suspect it's good because it passes signal through here. This is our A to D converter and our DSP. This is where I'm focusing now, which is why I had to disassemble the front panel. And there comes a spam call number 20 on my work phone. Anyway, I checked this dual op amp because this takes signal from here and puts it into the A to D converter. And I had nothing coming out of these. So I measured the DC voltage and I got my -6, but I'm not getting my +6. It's getting onto the board, but it's not making it over to here. and I believe this is a problem with this section. So I'm just going to run a small thin jumper from the positive 6 over to here and see if it feeds everything else that's on that circuit, because there is quite a bit on there. If we look here, this is our dual op amp. This is where I'm not getting my positive 6 volts in, and it goes and it feeds a lot of other things in here. So I suspect if I get some power over to here, it may start to work. Anyhow, that's the theory we're going on. I'm going to jumper that wire, and before I do, I'll show you what I found and why I want to do what I want to do. Okay, so our dual op amp is this inline package right here. And that is these two guys here. They're in a single package. We want to look at the 4 volt, which I believe has our negative 6, and we want to check out the number 8 pin, or pin 8, which should have our positive 6. So the meter's here. I'm going to try and do it so the camera doesn't autofocus on me. Let me see if I can bend this chip over. Might be able to get that from the back. Probably not going to be able to see, so forgive me, I got to put the visor on. By the way, this is why I always keep pieces of cardboard here, so I can do things like this. Okay, so it's on. Okay, popped out of protection. Let's see here. There's our negative 6 at pin 4, but pin 8 has negative 0.95 volts. So what I'm going to do is I'm just going to run a thin jumper wire over from our positive 6, because our positive 6 comes in right here. It's 5.6, but it's close enough. And I believe our negative 6, and I verified this with no meter check. That's our negative 6, and that's definitely going over there, and it's making it. So I'm going to run a thin jumper wire. We're going to see if this thing works. Okay, as much as it pains me to do this, I'm going to have to throw in the towel on trying to get the DSP working on this. If you recall, what I found was that we were missing the positive 6 volt. There's supposed to be a positive and negative 6 volt that come onto this board and feed the DSP. But when I ran a jumper wire and connected the DSP, or connected the positive 6 volts to where the DSP would pick it off, it would pull the power supply down so badly that the unit wouldn't even turn on anymore. And if you recall, the regulator got so hot it unsoldered itself, and there's got to be a reason for that. Now, it's not doing that now. Now the power supply is folding back. It's going into hard current limiting, and is putting out maybe 2 volts positive and about a negative 0.9 or negative 1 volt at the negative 6 volt supply. So I tried unsoldering. I tried checking for shorts on all the filter capacitors on the line there. That's all these 100 microfarad 6.3 volt ones. They all check okay. There's no shorts. I unsoldered this IC, this IC, this IC, this IC, and this IC, and I was not able to find what's pulling the power supply down. Now on the back of the board, we've got 3 flat packs. 2 of them I think are either SRAM chips or SRAM, and the other one is the actual DSP chip. They're flat packs. I don't have the equipment or skill to unsolder those, so I'm just going to have to give up on this. I did try to get it going. I even replaced the 6 volt regulator, and it did increase the 6 volt from 5.6 to 6 volts. So I'm glad I did that, because the heat may have damaged it. But we're going to have to call this done. We repaired the tone control, we repaired the remote, and I'm just going to have to give this back to my friend as is. I'm unable to find the problem with it. I hate it when that happens, but you have to know when to call it quits. So anyhow, I'm going to put this together. We'll listen to a little YouTube safe music through it, and we're going to call this one done. And it's time to get back to that Luxman. By the way, I just want to give you a quick view here. This is what my bench looks like when I'm deep in a project. It's a mess. I, for some reason, tend to thrive in chaos. I don't know what that says about me. I'm not sure I want to know. But anyhow, there it is in all its glory. Okay, I've got this thing completely reassembled. So we're going to try the remote here, turn the power on. Power comes on. Let's see, we want CD. Popped out of protection. There we have CD. And now the volume control. You can see the little red LED there. And everything seems to be working on here. All right, so that concludes this video. Folks, sometimes there's things that I just can't fix. Maybe somebody else could have got this one, but I believe the problem was one of those flat packs, or it could have been the circuit board itself. In any event, you have to know when to draw the line on some of these things. I would like to have gotten everything going for my friend, but it just wasn't in the cards on this one. So I'm going to call this video done. Thank everybody for watching, and as always, I like giving back to the community that has given me so much. Thank you very much.